This is all about your choice.
What's it out of?
Huh?
What's it out of?
It's out of 10.
Out of 10.
It's out of 10. So, I am going to go through, I'm not going to go through every problem on every quiz, but I want to make sure we do one of each of the kinds. So, who would like me to do a particular problem? Kyla.
3 hearts number 1.
3 hearts number 1. So, the 3 heart number 1 says we have a 5 card hand and we want 1 jack, 1 king, 3 aces. Okay? So we want a 5 card hand and it says how many. Now, this is one of the things that I think caught some of you. You have to read carefully. If it says probability, what's the probability? Then you know you're going to have a fraction, right? But if it just says how many, then you just want what would be the numerator only. You're not dividing by anything. How many means you're going to get an answer like 16, not an answer like 0.451. That doesn't make any sense. Do you see what I'm saying? So when you read that, maybe underline it or highlight it or something so that you know, oh, this isn't probability, or this is probability. This one is how many. So it's not a fraction. I'm just going to figure out, I need 1 jack, 1 king, 3 aces. So here we go. How many jacks are there in the deck? 4. How many am I picking? 1. Done with the jacks. How many kings are there in the deck? How many am I picking? Done with the kings. How many aces are in the deck? How many am I picking? Done. Now, since I am picking 1 jack, 1 king, and 3 aces, what am I going to do with these 3 numbers? Multiply. And means multiply. I don't know how many more times I can say that, people. And means multiply. Okay? So you just multiply them all and get the answer. And the answer is 64 ways. Or 64 hands. That's how many hands. Now, let's do one more card problem from another quiz. Who has it? Does anyone have a card problem? Allie?
Number 1 on 2 hearts.
2 hearts, number 1. Says, how many 5 card hands contain no more than 1 jack? What does no more than 1 jack mean?
0.
You could have no jacks, or you could have 1 jack, right? And notice I'm actually physically writing that down to draw my attention to the details. How many cards are in this hand? If none of them are jacks, then what are they? Anything else. So there are no jacks and 5 others. What if one of them's a jack? Then so 1 jack and 4 others? How many jacks are in the deck? 4. How many others are in the deck? 48. So I don't want any jacks, but I want 5 other cards. So if you want to put this on there, you can, but you don't have to. That would be no jacks and 5 other cards. Or 1 jack. What's that look like? 1 jack. 4C1. And what does 4 others look like? 48C4. Now again, this was how many. So that's it. That's the answer to the question. No denominator, because it's not a probability question. It wants to know how many. So when I type all that in, it's actually a great big number. It's that many hands are possible. Bryce?
I was just going
Okay, all right, just hang on. Okay, so we good on that? That's how we do that kind of problem. Okay, so Bryce for two.
One heart, number one. And that's a probability one.
Okay, I'm not gonna do every problem on every quiz, guys. So, I had hoped that doing these two, you'd be able to get that one. So we're not gonna be able to do all these problems because we don't have time, but here we go. Four cards are dealt from a standard deck. What is the probability of exactly 3 diamonds? So it's gonna be a fraction. What does 3 diamonds mean? It's a 4-card hand, so I'm gonna have to get 3 diamonds and 1 other card. What do 3 diamonds look like? How many diamonds are in the deck? 13. How many am I picking? 3. And how many other cards are in the deck that aren't diamonds? 39. And how many am I picking? 1. So there's my numerator. I have 3 out of the 13 diamonds, and I have 1 out of the 39 other things. Now, what's my denominator? 52C4, because there are 52 cards total in the whole deck, and I am picking 4 of them. And that is 0.0412 if you do it in decimal form. Okay, I'll do one more problem. One more. So who's got one more question to look at it? And I raise your hand up.
Yes, sir, I was scratching down there.
Okay.
1 heart, problem number 4.
1 heart, problem number 4. There are 67 students in the cafeteria. 30 of them like soup. 53 like fries. 12 don't like either. So in terms of the circles, 12 are outside of them. I have a soup circle and a French fry circle, and 12 people are outside the circles, right? So what does that mean about the number of people inside the circles? Inside the circles would be how many people? How many? 55. There's 67 total people. 12 of them aren't eating. So how many are eating? 55, right? Now, how many are eating soup? 30. How many are eating fries?
3.
How many is that? How many things are being eaten? 83 things, right?
Yep.
Well, wait a second. There's only 55 people.
Twice.
So if 83 meals have been eaten, what does that mean? Some people ate both things, right? How many people had to have eaten both things? We had 83 meals eaten by 55 people.
32.
So that would be, what's 83 minus 55? Is that 28? So 28 people must have eaten both. Think of it as you got a big serving line, and the cafeteria people counted, and 83 things came off the serving line, but only 55 people went through. So 28 people had to have taken more than one meal. All right, so what does that mean? If that whole circle is 30, there must be 2 here. And if that whole circle is 53, there must be, what, how many would that be? 25? Now, this is what I wish you all would have done if you missed this problem. I wish you would have added up this number, this number, this number, and this number. Because what do all 4 of those numbers have to add up to? 65, or 67. That's all the people that you have. So if your numbers don't add up, then you can't have it right. So what's the question? The question is, how many like only soup? So only soup would be 2 people. All right, now I want to do one with the probabilities given. Do one of those. So who's got one of those you want to do with the probabilities given? Logan?
1 heart, number 2.
No, I'm doing number 3.
Number 3, yeah.
Yeah, that's the one I want to do. Yeah, that's the kind of problem I want to do. So, given on the 1 heart quiz was this information. Okay, so I'm going to draw my Venn diagram, and I got my C and my D. Now, if C is coconut and D is daffodils, then the probability of picking someone who likes coconut is 0.8, and someone who likes daffodils is 0.4. What does this mean? We like coconut and daffodils, so that number I can put right in there, right away. If the whole daffodil ball is 0.8, then this part has to be 0.5. And if the whole daffodil ball has to be 0.4, this has to be 0.1. Now, in a probability in this one, we had to total 67 because we had 67 people. But in a probability problem, we have to total 1. So what have we got here? 0.9, which means the other 0.1 doesn't like daffodils or coconut. Okay? So now here are the questions. All right, what does that top one mean? You don't like coconut. Right?
1.2, right?
Now this is really simple. If the probability you like coconut is 0.8, then the probability you don't like coconut is 0.2. You don't need a diagram. It would be everybody outside the ball, so that's that 0.1 and that 0.1. But you can tell it from right here. You either like coconut or you don't. So if you have 80% chance of liking it, then you have a 20% chance of not. Same concept as when we build our Venn diagram. Remember, if we put a 0.8 on that one, what do we put on this one? 0.2 every time. So that's 0.2. Now what does this one say? I like coconut, but I do not like daffodils. Okay, so look at your picture. Where are the people who like coconut, but they don't like daffodils? Right there. It's them. Right there. They like only, another way of saying that is they like only coconut. So that would be 0.5. Okay? Now that's all the time I'm going to give to this. Again, if you want to redo it, you absolutely may after school, or you cannot. It's up to you completely. I don't care. I haven't put them in power school yet, but I will as soon as we figure out who's taking it or not taking it.